So today you're going to use some of the division strategies you learned to solve word problems. We learned how to repeatedly subtract. We learned how to deal out the total, and we learned how to use arrays. Most of what we were doing in class was actually using the dealing out strategy. So let's look at this word problem together. There are 28 desks in the classroom. The teacher puts them in groups of 4. How many groups of desks are in the classroom? Just like we did with the multiplication word problems a couple of weeks ago, we're going to pick out the context clues, the important information. It's important to know there's 28 desks. That's my total. And the teacher puts them in groups of 4. That's how many go into each group. We're being asked how many groups of desks are in the classroom. So I don't know the number of groups. I know how many goes in each group. So I can count it out like this. 1, 2, 3, 4, and make a group. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So if I have a total of 28 and I put it into groups of 4, means I'm going to end up with 1, 2, 3, 4, 5, 6, 7 groups. If you read it and thought that you were making 4 groups, you could do that. You wouldn't be exactly representing each part correctly. And if you dealt out the 28, then you would give each of the 4 groups 1 until you ran out. So we could look at it that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So if I have 28 and I put it into groups of into 4 groups, I'm going to flip flop it. Then I'm going to end up with 7 in each group. And I actually wrote them the same. It really does not matter. If we go by the model, 28 put into how many groups? It would actually be how we did this over here. Put into how many groups? 7 would be 4. Not trying to confuse you. The point is, it doesn't matter what order that you put the first and the last number in, because you can flip flop them around, because division and multiplication go together. So let's try another one. 3 friends are given a pack of trading cards to share equally. The pack contains 18 cards. How many cards should each person get? The important information, 3 friends. That is in word form. When you start a sentence, you have to spell it out in word form. If it's actually a digit, you can't start a sentence with a digit looking like a digit. But what I do when I'm given a word problem and it is in word form, I just put the digit that the word represents right up above it. They're given a pack of trading cards to share equally. That's important. That's letting your math brain know, hey, I am going to divide. Each of the packs contains 18 cards. That's important. And so how many cards should each person get? I have a total of 18 being shared among 3 friends. So here's my 3 friends. They're also considered my groups. And I'm going to share out the 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 cards shared among 3 friends means that each friend gets 6 cards. And that's answering the question I'm being asked. You can check yourself with multiplication. You've learned your 3's facts. So if I say the problem backwards, 6 times 3 equals what? 18. So that means I wrote this division problem correctly. Figured it out. One more. Becky has 30 flowers. She wants to put them in bouquets of 5 flowers each. How many bouquets will Becky be able to make? It's important that she had 30 flowers. That's my total. She wants to put them in group bouquets or groups of 5 flowers each. That's putting them in equal groups. So how many bouquets will Becky be able to make? How many groups? If you're going to put 5 flowers in each bouquet, 1, 2, 3, 4, 5, that's a bouquet. 6, 7, 8, 9, 10, that's another one. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And I bundle them up, group them up. Then you can see that 30 flowers put into, with 5 flowers put in each bouquet, each group means you're going to end up with 6 bouquets. Same thing like I showed you last slide. If you want to make the 5 and deal out the 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that would show that you have 6 in each one of those. The quick check. If you will read this, pause the video, and try to work it out on your own, and then check back with me to see if you got the same answer as I did. Look for the important information. Pull that out. 7 children are building toy cars. They have 28 toy wheels to share equally. How many toy wheels will each child get? So 28 is my total. Divided by 7 is how many? If you make your 7 groups, or you could do this in an array actually. People just get used to doing the groups. That's what most children are comfortable with. And count out the 28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So there will be 4 wheels that each child will get. That's it for today's lesson. If you will work, there's the vision word problem math practice page, and I think there's 5 problems on that. If you will practice pulling out the important information, the numbers and keywords, and then drawing your model, then writing the division sentence that your model represents, including the answer. Please let me know if you have any questions.